A return to aerodynamics. The B-2 Spirit.
One of the advantages of a flying wing is it's a very efficient airplane because it's nothing but a wing. It has very little drag, so as a result it has very good long-range performance.
The B-2 has the wingspan of a jumbo jet. It can fly 8,000 miles before it needs refueling. The flying wing's low drag means not just increased range, but even greater payloads. The B-2 has, in fact, a solid pedigree, one that predates the computer. The secret of how to make a wing fly lies in a dusty hangar at the Planes of Fame Museum in Chino, California. It's a craft built by a man who, in the evolution of the airplane, thought the fuselage and tail to be redundant. The inspirational father of the flying wing, Jack Northrop. He built this to prove that a wing alone was capable of controlled flight. Instead of a tail, he devised an ingenious method to keep the aircraft flying straight. A set of flaps that opened like a clamshell at the end of each wing. When one clamshell opened, it would create drag above and below the wing, acting like an oar plunged into the water at the side of a speedboat. In 1940, Jack Northrop's prototype took to the air. The clamshells worked. He was convinced this was the shape of the future.
The point of it was it demonstrated that you could actually have a flying wing that did not have a rudder and a vertical tail, and yet the plane could still fly quite safely.
When the Army saw the prototype fly, they thought it would be the answer to their search for a new long-range heavy bomber. They ordered 13. As the planes entered their test program, they discovered the all-new jet-powered YB-49 displayed worrying characteristics.
It had problems in the sense that it was neutrally stable. It had a tendency to wallow somewhat, is the best way to put it directionally, because it didn't have a tail.
During flight, the clamshells demanded constant attention just to keep the plane on an even keel.
The pilot had to damp out all these uncommanded motions. As a result, his workload was increased tremendously.
A system of gyroscopes helped to keep the plane stable, but the problem wouldn't go away. And on June 5th, 1948, disaster struck. On a test flight just north of Muroc Dry Lake in California, a flying wing crashed, killing the entire crew, pilot Glenn Edwards included. The Air Force Base bears his name to this day. But if Edwards' name lives on, Jack Northrop's was heading for the history books. The control problem that eluded Jack Northrop was instantly overcome by the application of the flight control computer.
You have gyros inside the airplane that sense when the airplane moves uncommanded without the pilot commanding it to move. And it automatically, without him taking any actions, moves the control surfaces in order to kill that motion.
As a result of the flight control computer, the flying wing was resurrected in the shape of the B-2. But it wasn't the only reason. Back in the 1940s, when Jack Northrop's flying wing bomber was undergoing development, so too was radar.
One of the things that was noticed during the testing of the YB-49, and it was just sort of as an afterthought, was it was very hard for the radars to see the flying wings. And they actually did do a flight test where they actually deliberately flew at a radar and said, okay, tell us when you see us. And it was surprisingly close to the radar before they actually saw them. But no one was particularly interested in that, and they just filed it away.
The battle with radar pushed aviation technology to the limit. The F-117 and B-2 are the first and second generations of stealth. The Raptor is the latest.